All right. Let's look at combinations. I'm going to contrast. Well, let's first define combinations. Combinations, we'll say, are the ways.
Yes, totally.
Supposed to be a D. The ways to do something when the order does not matter. I want to contrast that with what we did last Thursday, which was permutations. If you recall, permutations were lists, so that's when order really mattered, in which I chose them. Combinations, it's not so much. The classic example of the difference between a permutation, what we did last week, and a combination, what you're doing this week, or what you're doing today, is the following. We're going to look at committees.
You have really small
I'm trying.
I'm trying.
And we'll reserve a formula over here.
That's water.
Yep, that's supposed to be committees. So this is an example. This is an example of the difference between permutations and combinations. Okay. Committees. Just all it says is the word committees right now.
How committee doesn't sound like a word?
Okay. Here are two different ways you can talk about a similar problem. How about in this first example, you have 10 people in a room, and I want to find how many. Well, that's probably tough to read. How many groups have a given president, vice president, and secretary? How many groups have a given president, vice president, and secretary? So I want groups of 3, and I want to pick a president, then a vice president, and then a secretary. Okay. In this case, does it matter which, if I pick 3 people, does it matter which order they got picked in? So, for example, if say Tyler and Maggie and Jessica were the 3 picked, would having Tyler the president, Maggie the vice president, and Jessica being the secretary, would that be the same or different than if Maggie was the president and Jessica was the vice president and Tyler was the secretary? Are those different things or the same things? They're different. That means that the order in which I pick them actually does matter. It's like a first place, second place, third place. You can think of it. This is an example of a permutation. These are the things we were doing last week. Okay. I'm going to compare that, or contrast that, I guess, with this problem. I have 10 people.
You have 3 janitors. 4 secretaries.
What have I brought home?
Compare that with just this question. You have 10 people to pick from. How many groups of 3 are possible? So I still have 10 to choose from. I'm still picking groups of 3. But in this case, does the order in which I pick them matter? If I have, say, Bree and Joe and Brooke, does picking Bree then Joe then Brooke, is that a different group than picking Brooke then Bree then Joe? No, I just need those 3 in the group. The group is still the same. This is an example of a combination.
Those are funny.
In the first group, the order mattered because there were specific slots for them. Versus in this case, all I want are the three. I just want the three people. I don't care what order they came in. I don't care when they are. I just want to make sure that I have the same three people. So an example of a combination. Okay. Our formula for calculating combinations will be the following. Okay, I'm going to write it like this. For n is equal to the items to choose from. If say R is the size of the group. If I want to look at the number of combinations here where I don't care if the order matters or not, we'll say this. This is the calculator will say NCR is the button you'd use or the function. Your book will see NCR as well for combinations. That's the same as look at all the permutations that are possible. So find how many lists are possible if you care about the order, and then divide it by how many you picked, by the size of the group. So NPR divided by R factorial. If you really want to, in terms of just factorials, it would be n factorial over n minus r factorial times r factorial.
Famous.
I want to try to talk about setting up problems in terms of using this idea, looking at how many lists are possible, and then how many ways are there to rearrange those lists, the lists of that size. If you really want, this is a little more formal definition. If you want to just plug in numbers and simplify, kind of like some of you did with the NPR stuff, it's kind of the same game, but I'll go there. I like this thought process because we're going to think about our problems in terms of kind of like how many ways, and then how many to do something. How many ways can we rearrange them? That's an arrowhead, and for some reason I drew like a line underneath it. I don't know. That's pointing to this is how I'm gonna. This is the thought process I'm gonna use. They both give the same answers, but I'm gonna use this thought process. I'm going to find how many ways there to list them, and then how many ways could you rearrange them once you have them in a list. Okay. So, for example, let's count the combinations of 2 letters from this list. Combinations means I don't care. So, for example, this combination of A then B is the same as this combination of B then A. I just want them in my group. So I want to be able to count how many ways there are to do that. So if I'm thinking of this formula method here, how many items do I have to choose from? How many items do I have to choose from in here?
4, 5.
1, 2, 3, 4, 5 of them. What's the size of the group that I want? 2. So if I'm thinking of this formula, I want to come up with how many lists of length 2 are there possible?
5.
Just 5p2. So what is that number? How do I calculate that? I have 2 spots and I start at 5. Because I have a list of 2 items, and I have starting with 5 choices, and then I lose 1, so it's 4. Okay, and I want to once I find out the list, then I want to divide them or figure out how many ways there were to rearrange them.
2.
Or there were 2 factorial ways, which 2 factorial, as you calculate, is just to be 2. So what's 5 times 4 divided by 2? That's 20 over 2, or 10 combinations.
Yeah.
Wait, why are you putting it over 2? Because She likes it over 2.
Wait, where'd that five?
Okay. This is the number of lists I could make of size 2, which is 5 times 4. But that's assuming that I care that the first one came first and the second one came second. If I just want 2 in my group, I don't care whether the A came first or came second. Then what I'm doing is figuring, well, now it's like pick my 2. How many ways could I like rearrange them? So if I have now 2 letters, I want to arrange 2 of them. That's 2p2, which is 2 factorial. So I could have rearranged these 2 letters I picked in 2 times 1 ways, or 2 ways. So I divide this list of these 20 lists in half, because half of them will be the same. Okay. That's what this formula here stands for. If you want, you can just plug in here. Either way, you're going to get the same number. But there are 10 possible combinations. So kind of same line of thought here. So I'm going to choose 2 courses out of some list of 6. How many different combinations of these electives are possible?
There are
Well, I have 6 choices, and I'm picking 2. In a group. All I want is to make sure that I have the two classes. I don't care what order I take them. I don't care when the day I take my classes. I just want these 2 in my group. So that would be in our notation here, 6C2.
you right.
There we go, that's love.
So it's the same thing.
Because if you in our little formula here, NCR is the same as NPR over R factorial. So I have 6 choices. I want 2 in a group. Well, that's the same as 6p2 over 2 factorial.
Wait, can you go? I have to push it over this way first. I can't see. He's put it over. Impossible.
So it's 6p2 over 2 factorial. 6p2 is lists of 2, and I have 6 choices. 6 for the first number, 5 for the second. And I'll divide that by 2 factorial, which is 2 times 1.
Oh, dude, I was writing down the wrong line. Cocoa Puff.
Can you turn it the other way? It's fine. It's the other way.
All right, last but not least here. It says your teacher chooses 2 out of the 18 students here to give an impromptu debate on freedom of press in some high school newspaper. So the Squall,
Oh, wait.
they walk into a class of 18 people and they say, you and you, come here, and let's do point counterpoint. And you start talking, and the other person talks about the other side of the issue, and they write it down. Okay. What's the probability now?
I want to keep it that way.
What's the probability that the group that's chosen is you and your best friend?
You have a 2 out of 10 chance.
In this problem, we're implicitly assuming that you have a singular best friend. You have one BFF. And I want to know the probability of this. So let's make sure we write down, make sure we know the probability is, in our case, we want groups with you and your BFF.
Oh my god, so funny.
And I want to know the total possible groups. Okay. So then we're talking groups here. So I don't care. I don't care which order I get picked. I just want to make sure in that group of 2, it's me and my best friend.
Which is me, so. Me and Fisher.
Mr. Fisher, who's your best friend? Yeah, Mr. Fisher, who's your best friend? Is Mr. Parker your best friend?
It's that lamp right there.
Okay.
I love lamp.
It's Mr. Fisher.
Oh.
How many groups? How many groups have both you and your best friend?
It's enormous. It's a huge number.
How many groups of 2 contain you and your best friend?
Am I doing this right?
There's one of them.
Best friends in the past.
Oh.
There's only one way to get a group of 2 with you and your best friend. It's to pick you and your best friend.
Oh, totally possible groups. That's when I was.
Okay. What's more important to us, I guess, let's require a little more thought, is how many possible groups of 2 are there?
9.
Well, there's more than 9.
You sure?
I am positive. If I want to find the total groups,
10.
I have
10.
18 people to pick from, and I want them of size 2.
I said 9.
So that amounts to calculating what 18C2 is. 18C2 is
306.
18P2
306.
over 2 factorial.
I'm right.
18P2 is 18 times 17. 2 factorial is 2 times 1.
Oh, yeah.
7,
We should have that. I like kindergarten.
306 over 2. Okay, what's 8?
There are 18P2 lists of 2 people with you if you have 18 to pick from. And we could rearrange them 2 times 1 ways. 18 times 17, who said
306.
306. There are 2, we could rearrange them,
150.
which means the total possible groups of 2 are 153. So your probability of, if you just pick at random, the group with just you and your best friend is 1 out of 153, which as a decimal is about 0.6%.
But there's still a chance.
There's still a chance. It's not a good chance, but it's still a chance.